Today we are going to look at how we factor trinomials when a is not equal to 1. So the first thing that we have to remember is that a trinomial is something with 3 terms. So everything we're looking at today is 3 terms. Okay, and it's important that those 3 terms are in standard form. So standard form means we have the highest degree to the lowest degree. So since we won't be looking at multiple variables, we'll be looking at the largest exponent to the smallest exponent. And in fact, it needs to be even more specifically in the form ax squared plus bx plus c. So while it would still be 3 terms if this was an x to the 3rd power, everything we will be looking at will be a quadratic trinomials. Remember, quadratic means a degree of 2. Now, the key here really is that we can't factor something that is 3 terms, but we do know how to factor something that is 4 terms. So we want to decide how we can rewrite 3 terms into 4 terms so that we can factor it by grouping. Okay, and the way that we are going to do that is to first check and make sure we are in the correct form. So 2x squared plus 11x plus 5, right, is the form ax squared plus bx plus c. So the first thing that we want to do is we are going to multiply a times c, right? So a is the number in front of the x squared, c is the constant or the number by itself. So as long as we're written in standard form, we're going to multiply the first number and we're going to multiply the last number. So 2 times 5 gives me 10. My second step is going to be to list numbers. Right? Numbers that multiply to 10. So numbers that multiply up, we want like factors because they divide evenly into it. Right? So they're going to give us a times c. A times c was 10 in this specific case. So what I'm going to do over here, how I kind of like to write it, is I like to go in order. So instead of thinking of random numbers, I first try 1. So 1 times 10 is 10. 2 times 5 is 10. 3 times nothing is 10. 4 times nothing is 10. And then the next number that I would write down is 5, and 5 is already over here in my list. Now, if you say you're not super strong at your factors, you could use a calculator and you could take 10 divided by 1, which gives us 10. 10 divided by 2, which gives us 5. 10 divided by 3, which gives us a decimal, so that won't work. Okay, then we want to find the pair that adds to b. Okay, we're going to find the pair that adds up that has a sum of b. So if we remember, b up here is our middle term. So when we're looking at our trinomial, we want our middle term. Okay, so our middle term is 11. So I'm going to start adding up these 2 pieces. So I'm going to say 1 plus 10 equals 11. 2 plus 5 equals 7. Okay, I want whichever one adds up to this middle number. So that's 11. This is 11. So I want this 1 plus 10. So I have to pick that pair. I cannot pick the other one because it does not add up to 11. It adds up to 7. Okay, then I'm going to rewrite this trinomial into 4 terms. So I'm going to take this b value and I'm going to split it up into 2 different pieces. So instead of saying 11x, I'm going to pick my 2 numbers that I picked and I'm going to make that a positive 1x and a positive 10x because 1x plus 10x is 11x, right? I'm still representing the value 11x. I'm just representing it in a different way. Now my in term, my c value is going to come straight down. And my ax squared is going to come straight down as well. Right? So I'm still talking about the same value. This still holds the same value. I just have it written in a different way. My next step is now going to be to factor by grouping, which we've already talked about how to do. So if you're not sure how to factor by grouping, you're going to need to go back and watch the old notes over how we factor by grouping. right? But factoring by grouping says I'm going to split this in half. I'm going to factor my GCF out of the left. All right, I'm going to factor my GCF out of the right. So 10 and 5, right, that's 5. They do not both have an X, so I can't pull out an X. Now, if you're like, what the heck is going on? I don't know how to factor by grouping. Again, you're going to want to go back and watch the factoring by grouping notes. Right? Our two GCFs go together. And then our common binomial goes together. So let's look at a couple more of these examples. So if we look at number 2, again, we're going to start by multiplying A times C. So I'm taking 7 times 2, which gives me 14. And then I'm going to list numbers that multiply up to 14. So 1 times 14, 2 times 7, 3 times nothing, 4 times nothing. Now, a lot of students will say to me, Mrs. McKinney, I know that I'm out of choices. I don't have to get all the way down to 6 before I write 7. That really is fine. It's just that you'll see as we get to some more complex ones, your list is going to be long, and so that's a good way to help you know. Okay, so we want to find the pair that adds up to, so 1 plus 14 is 15. It needs to add up to B, which is 9. 2 plus 7, oh, that's our pair. That gives us 9. So I'm going to split this middle term up, right? I'm going to rewrite that as a 2x, a positive 2x, and a positive 7x. Bringing down my last term. Oops, this has an N and an X. Let's make these letters all match. That's a typo. Okay, then we're going to factor by grouping. So we're going to factor out a GCF. So over here we'll have a GCF of N or 1N, either way you want to write that. Right, over here we'll have a GCF of 1. Our GCFs go together. Now, I would really suggest at this point that you are pausing the video, you are going through and doing the remaining of these problems, and then checking your answers. So I'm going to go through these last ones sort of quickly. Again, I think it'd be a good idea to pause, try and do some on your own, and then check the answers. So here we go with 3. 3 times 4 is 12. So 2 and 6 is going to add up to B, which is 8. We're going to factor by grouping. And we'll get a y plus 2. Oops, and a 3y plus 2. Number 4, 3 times 3 is 9. Okay, our set that adds up to B is going to be 1 plus 9. It does not matter which order you write these middle two terms in, you'll still get the same two binomial answers. Number 5, we'll take 12 times 5, which will give us 60. And again, if you need to pick up your calculator and divide those each, that's fine. Right, here's gonna, see, do we have our set? 4 and 15. I'll factor by grouping. Number 6. So this is a common one. My students will start just thinking of numbers that give them 64, but again, really go in order, because as soon as we do that first one, 1 times 64 is our set that will give us 65. Now, this last one is sort of the one that I was referring to. So I don't look at 24 times 12 and like magically think of numbers that add up to 41. So again, like I was saying, if you need to use your calculator, sort of pick out pieces here. So that gives me a 288, which is huge, right? So I might be going 1 and 288, 2 and 144, 3 and I don't know, right? So I might have to be checking in my calculator. You just have to kind of be consistent and go down the list. So I'm getting closer. 7 and nothing. Right, I'm just typing in my calculator 288 divided by 8. That's not it. All right, and there's my set, 9 and 32. So I really did just have to kind of be consistent until I found the correct pair. Now you might have to go longer and then go back and add whatever you need to do. Right, if you pick the wrong set, you will not factor this correctly. Oh, let's see. So we'll get a 3y plus 4 and an 8y plus 3.